Hey, what's up? Samuel here. In this video, we'll learn how search algorithms are used for solving problems in AI. In fact, all problems can be phrased as search problems. I know there are a lot of definitions out there about what search algorithms are, but there's this particular one I want to sort of focus on. Search algorithms retrieve information stored within some data structure. So don't try to understand this right now if it doesn't make any sense. You understand what I mean moving forward. So imagine you're in a foreign city at some address, say a hotel, and want to use public transport to get to another address. A nice restaurant perhaps? What do? If you're like many people, you pull out your smartphone, type in the destination, and start following the instructions. This question belongs to the class of search and planning problems. Similar problems need to be solved by self-driving cars and perhaps less obviously AI for playing games. In the game of chess, for example, the difficulty is not much so in getting the piece from A to B as keeping your piece safe from the opponent. The same applies to the tic-tac-toe game. So let me use this opportunity to sort of establish a baseline here and define some of the terminologies that we're going to use. The first one is agents. So what is an agent? Well, an agent is an entity that perceives its environment and acts upon that environment. So in the case of our direction, your agent might be a representation of a car that's trying to find a direction to the destination. In the case of a tic-tac-toe or chess, your agent might be the person or the AI playing the game. So next, we introduce the idea of a state, which is a configuration of the agent and its environment. So in a self-driving car, for example, any state might be any one of these, a configuration of the agent and its environment where each state requires a sequence of actions or direction to move from the initial state to the goal or destination. So initial state, what is it? Well, the initial state is the state where the agent begins. So in our case, the hotel, where the self-driving car begins or starts from. And to get to the destination, it needs to take some set of actions to get there. And what are these actions? Well, actions are choices that can be made in a state. And we already know that performing an action on an already existing state results to another different state. And this is what gives us the transitional model. And this is a function that receives the state as a first input and the action as a second input and returns a result or a different state. So let's take an example to understand more precisely what I mean. This is a state of our self-driving car. And here's an example of an action, taking the right turn. So what happens when you put these to the result function? The result function takes this state as a first input and takes an action as a second input. The output is a new state, and this describes how states and actions are related to each other. So now we know that given an initial state, an agent takes an action which results to a different state or transitional model. Now, what about the other possible actions that the agent can take? What if instead of a right turn, it made another right turn or went straight ahead and then took another left turn or right turn? That's what's called the state space. And that is the set of all states reachable from the initial state by any sequence of actions by taking one or two or more actions in addition to that. And that can visually be represented like this, for example. Sometimes our state space is going to look much bigger than this. And so just for simplicity, we'll simplify a representation of this entire thing as a graph. Some sequence of nodes and edges that connect nodes. And this representation is the exact same idea. Each of these nodes represents a state, and the edges represent an action taken from one particular state to another. In AI, you're going to hear a lot about graphs. Each of these nodes represent the states, and the edges represent some particular action that is taken from one particular state to another. Now, the next step is how the AI is going to know when it's done. The AI needs to know when it's found the goal. So the next thing we need to encode into our AI is the goal test, which is a way to determine whether a given state is a goal state. So in our case, for example, the AI knows it reached the goal when it's at the exact position we set as our destination. Now, some problems might have one goal, but more complex problems have more than one goal. Sometimes a computer just doesn't care about finding the goal, but finding the goal well or with a low cost. And so our last piece of terminology is the path cost, which is a numerical value associated with a given path. And the cost can be in terms of money or time. So in that case, how does the AI find a path that has a lower cost? So how long in time does the AI take to reach the destination? Maybe the car took a route with unnecessary detours and directions that were unnecessary that took longer than it should have for me to get to the destination. So in this case, it has a much higher path cost. And in AI, it's going to use optimization to find the lowest possible path cost. So in this video, we've introduced the idea of agent, state, action, transitional model, goal test, path cost. In the next video, we'll look at different types of search algorithms there are and possibly show how they can be implemented with data structures. Thanks for watching.